Hello and welcome. My name is Alex Carney. I'm a researcher at OpenAI, and I'm here today at Argonne National Lab to talk about our 1000 Scientist Jam Day we're having today. I'm here with Rick Stevens and a panel from other national labs that Rick can introduce.
Okay, yeah, I'm Rick Stevens. I'm the Associate Lab Director here for Computing Environment Life Sciences. And on the webinar, we have Brian Spears at Livermore. Brian, you want to introduce yourself?
Hi, folks. I'm Brian Spears. I'm the director of our AI Innovation Incubator here at Lawrence Livermore National Laboratory, and I work with our senior leadership to build out AI strategy for our national lab.
And Prasanna from Oak Ridge.
Hello, good morning, everyone. Prasanna Balaprakash from Oak Ridge National Lab. I'm the director of AI programs, wherein I lead the AI initiative that is focused on various aspects of AI for scientific discovery, experimental facilities, and national security.
And Court Courtney from Canada.
Hi, Court Corley from Pacific Northwest National Laboratory. I'm the director of our Center for AI. It's responsible for advancing state-of-the-art in AI and its application across all of DOE's missions.
Great, thank you all. So we've got obviously a pretty experienced panel here to talk today. The part you can't see is downstairs. We've got here on site at Argonne about 300 scientists who will be participating here in the jam, and then over 1,000 spread across, I think, 8 other national labs who will be part of this. And so this is an exciting start of a collaboration between OpenAI and other AI labs and the US national labs. I really think it's the start of something. It's an exploration. We're calling it a jam because we really don't know where it's going to go. We've got a lot of excitement for where it could go. We'll have pizza showing up. We've got coffee already powering this. And so we're really going to see where we can bring AI and the national labs together to push the frontiers of science. So let me turn it over to Rick to tell us more.
Alex. I mean, when we started thinking about this last fall, the idea was to bring together 1,000 or more researchers and some of the best AI tools that the country has produced, and to challenge our scientific community to bring their hardest, most interesting problems to the table and spend a day in we call it a jam. It's kind of, imagine kind of like a jazz musicians getting together and just riffing and playing off of each other to explore what state-of-the-art models are capable of in the context of scientific problems, and to understand a bit better how far we've made progress, how much progress we've made, but also what are the gaps, what are the key directions that by collaborating with the national labs and the AI research labs in the US, can we really advance the frontiers of AI to accelerate science? That's the purpose of the jam. But it's also, as Alex said, to kick off what we think will be a long-term collaboration between the national labs and AI companies like OpenAI.
Yeah, it's an exciting event. I can pull ChatGPT out of my pocket, but it's not every day I get to pull 1,500 scientists with it to see where that goes. So excited to see what we produce today. So let's kick it off. I want to talk about what's happening with AI and science. So let's start with just the current state. So maybe each of the panelists tell me a little bit about what your labs are currently doing with AI.
Well, I can start. I mean, here at Argonne, we have longstanding research programs in biology and material science, energy storage and nuclear energy, national security, materials design. And every one of these areas is working towards using AI to both push the envelope on what problems we can work on, but also to accelerate the rate at which we can work on problems, whether it's from designing a new energy storage substance, a molecule or materials that can be used for a battery material, for example, doing that in a way that reduces the amount of time from when we have an idea to when we can do an experiment in a lab and actually build a prototype. In biology, we're using AI to help us understand emerging pathogens, to design cancer treatments and other things. So there's a lot of energy around what can AI do to help us accelerate both the pace of science, but also to increase the complexity of problems we can tackle.
Mm-hmm. From either of the other panelists as well?
Hi, yeah. What I think you'll hear from all of us across the labs that we're doing very similar things to what Rick is describing. The imperative is clear. The thing that I would refine is there's a big vision that we're producing. We see the chance for a scientific reasoning platform, the combination of what comes from US commercial laboratories in AI to do reasoning and solve problems, as you and Rick have been thinking about, but also to partner that with 8 decades of excellence from our national laboratories, where we have systems that tell us how the world works. If we squeeze it, get it hot, make it go fast. And putting those two things together, they start to identify the frontier that Rick's talking about. So what we're doing right now is taking those modeling capabilities and teaching them how to use tools to close their reasoning capability, to run the world's largest and most capable scientific supercomputers, to run the world's most capable laser facilities and accelerators. And we can answer all those questions Rick's talking about, and we're starting to see this emergent whole where we can do science for national security and science competitiveness in an integrated, cohesive way. And we're taking a step today to see just how close and tight that integration can be.
Yeah, let's talk. Yeah, go ahead.
No, go ahead, Prasanna.
There's one more quick perspective, and that
course.
is, in addition to the scientific discovery and national security, I think our ability to affect, the power grid and grid resilience and stability is really important. And we see that AI is really going to be a way to leverage all the capabilities that Brian just mentioned, that have been used for science and are being used in other disciplines, but also to help, drive grid security for the future.
Yeah,
I quickly want to add something on the energy production, right? So how we are using AI to design much more advanced nuclear reactors and produce much more efficient way of explore efficient ways of producing nuclear energy to fuel AI. I think our leadership in AI will be defined by how we apply advanced AI for these kind of cutting edge domains, and then use and reap the benefits of those domains, such as nuclear energy, to propel AI as a whole.
Yeah, I think energy is a theme that comes up in a lot of these. Is obviously an important part of it. Is the Department of Energy, National Labs. And maybe to kind of talk through this a little bit, I think it's interesting to really dig in on how AI is being used. Like, maybe tell me on some of these specific examples you brought up, what is the vision there of how not just the AI, but the scientists around it, the scientists with it, build this together and actually push the frontier as a unified goal?
Yeah, so I mean, one of the scenarios, right, is that you're trying to work on some complex problem, say in physics or say in material science, and you can use the current models to do math derivations, right, to do mathematical physics, to design a set of equations around the problem that you're trying to work on. That could result in then producing a code, right, that then runs on our supercomputers. It also could result in using the model to help brainstorm about hypotheses that you then want to test in a lab. But also the actual process of coming up with candidate designs, right? So whether it's a material or whether it's say a chemical for a drug or something like that, models are now good enough that you can describe the properties you're looking for. You can describe some examples from literature, from databases, and the models can learn from those examples to try to produce new examples that meet your criteria. This idea of forward design or even inverse design from just the properties. So we really see AI as becoming a partner in scientific research. Some people call these co-pilots or co-scientists or AI collaborators in science, but that's one vision, right? It's more of an individual person working with powerful AI. I think what Brian was talking about with this idea of a complex, right? This notion of a system that might have a core advanced reasoning model coupled to our supercomputers and to our automated experiments that all the labs are also building out with robotics and powerful databases and tools. Now we build like an AI-powered ecosystem that maybe could take on high-level tasks like explore a design space in some, say, device that we're working on and do that for days at a time, right, in between human intervention. So that's kind of the vision that we have. I think we're at early days with this, right? But what's going to be super interesting from today's event, our jam, is that there's many, many kinds of problems, right? We're going to have 1,500 people trying things. Each person will probably try dozens of problems. So we will have tens of thousands of examples of people attempting to push the edge with today's models. And we're going to look at that, right, as a community and try to figure out how can we improve this. So this idea of this grand vision for how we can use AI to accelerate and improve the science, but also this process of collecting thousands of examples that we will also use AI to analyze and help us figure out like where to go. I think that's the magic of today and the partnership.
Yeah, it'll be this cool self-perpetuating loop.
Yeah, if we can get it, get it off the ground, it'll autocatalytic and acceleration, right? We have to lift off. That's our goal.
I'd say one of the really fascinating examples that we've seen that's tangible is the DOE is home to incredible scientific instruments and facilities. These investments are in the billions of dollars across the department. And we have instruments at P&L that are really exquisite and measure really interesting properties in chemistry and material science and biology and proteomics and so forth. But one of our instruments is really complex to program. There's only one scientist that is able to interface with this instrument because it's so difficult to interface with. So the entire lab is dependent on this one, the entire research lab for this instrument is dependent on this one person. And some examples of early reasoning models that we've used, now that scientist is able to create configurations and experimental designs instantaneously instead of spending hours or days writing out the scripts for their colleagues to use these instruments. So now what we have is instruments that are highly, much more efficient. They're being used all the time, where before they couldn't, just because of our integration of using frontier AI or these reasoning models to help, design the configurations to use them.
Yeah, I like this idea of this just making frontier science more accessible. For my background is in math, and one of the things I always struggled with is it's in these such technical fields, it's so hard to engage in another field when your expertise is in one place, and it just brings that closer for you.
Yeah, I mean, current models are amazingly polymathic, right? In the sense that they know, they've been deeply trained on the literature across all the domains, and they're becoming kind of universal translators in science, right? They know math, they know the underlying principles in chemistry and material science and biology and so forth. And you can prompt them to create new ideas in the spaces in between current things that are known. And I think that's one of the types of problems that people are exploring, is in this kind of hypothesis formation, but not just grinding them out in some mechanical way, but really coming up with novel hypotheses and trying to help the model understand what humans think is novel, and to get models to create more novel things that we can then explore and challenge us. And I think that's part of what I think the community has to learn, is that science, of course, is deeply technical, but it's also a human activity, and human taste in problems matters a lot, right? And the questions matter a lot. In fact, it's often the case that the questions are more important than the answers. And one of the things that we want to make progress on is how can AI help us ask better questions? Prasanna, I know you're thinking about that too.
Yeah, so to add to what Rick said, right? So DOE is one of the largest producer of diverse scientific data, right? A reasoning model that can reason on multiple modalities, images, characterization data from experimental facilities, modeling and simulation, in fact, theory, right? So we have a lot of theoretical advancements in various aspects of materials and related fields. So a reasoning model that can sort of reason through multiple disciplines and be able to extract insights from one discipline and apply it to another one, right? So taking things from material science and help experimentations in chemistry, taking inspirations from biology and help material science, and so on and so forth. This is really, really an exciting area, right? So as a human, right, so we can be expert in not more than 1, 2, 3 areas, during our lifetime. But with the reasoning model, we can combine knowledge from multiple areas. And I think that is super exciting and very, very powerful. And that's going to redefine the scientific discovery in the DOE complex and across the world.
Yeah, if I could follow up,
Yeah, go ahead, Brian.
There's a really exciting thing that I think happens from that. I mean, Alex mentioned that he's a mathematician, but it's hard to access 1,500 scientists and the diverse background. And Rick, you mentioned the polymathic capability. Our national laboratories are really built to bring all of those disciplines together, the scientists, the engineers, the mathematicians, and answer big questions. But what we're finding is that the model capabilities to integrate that just takes the process time, the loop time, and puts us in a really tightly spinning inner loop where we can go from math to physics to chemistry to engineering and back on timescales we couldn't imagine. And what's emerged is the ability to attack these really substantial tech bogeys, these huge technical problems. And it can be reinforcing in the way that Rick said. So a good example, we're working on driving fusion with AI modeling. That we have a national laboratory here in Livermore where we've produced more energy from a fusion capsule than what we've used to drive it with a laser for the first time in human history. And AI helped us get there. It's one of our tools. But we also see a future now where these AI capabilities have the time that it will take to put fusion power on the grid from something like that. And we're building out this challenge problem, this moonshot, that we can only imagine because these AI tools have these polymathic capabilities to pull them together. And so there are these two levels of the conversation. This capability foundation that is emerging where we can just be competitive as the US on the global stage. And then these technical accomplishments that we can go after. And then there's some synergy. If we produce fusion with this, we meet the giant demand for energy that comes from driving AI systems. So we've got AI creating a demand, helping us build fusion, which produces supply to meet that demand, all to build a US techno-economic ecosystem where we have global advantage. So it's a really bright future that we see emerging. And today we take step zero on understanding exactly how tight that interaction can be.
Yeah, I was going to say, I think being here at the national labs and seeing this is really a testament to the fact that we've figured this out with scientists, with people, with humans, that you bring enough people together with different disciplines, you really get something out of that. I got the mini tour of the building on the way in and hearing all the way back to the Manhattan Project and the nearly 80 years of history driving US leadership in science. And I think it's a testament to the success of bringing these people together to work on big things together. And so what we're starting today and what we're looking forward to is how much more we can do with that as we add AI into the mix with all of those people.
Yeah, and we also see it's incredibly exciting for young people, right, for the workforce, to see that we're bringing the leading edge AI technologies and with leading edge scientific instruments. I mean, everybody's talking about the kind of instruments at P&L and Oak Ridge and Livermore and Argonne and other labs that are, in many cases, unique worldwide instruments, like the Advanced Photon Source here just got upgraded to the world's brightest X-ray source. It produces data 1,000 times more data per detector than we had before. It's so fast that there's no way to actually manage experiments manually with humans. You've got to wrap it with AI to make decisions and to have the next thing ready to go in order to get all the efficiency out of it. And that's both a challenging problem for the imaging scientists or the photon scientists, but also for the computer scientists and the AI and the mathematicians that's trying to pull this whole thing together. And it's a really creative space, right? Because these tools are so powerful now that in a weekend, I mean, you can write thousands of lines of code that advance your idea. On Friday night, you come home and you have this new idea by Sunday, right? You've got a prototype implementation that you can try out the next day. That kind of unbridling or whatever, unburdening of everything is amazing. And we're going to see more of that, but we also have to figure out how to integrate it into our workflows and into the way that we think about problems and problem solve. And of course, AI is not going to solve everything, but it is going to give us incredibly powerful tools, but we still have to work out what's the most important things to go after. And it will be a big help in actually sharpening our vision about what we should be going after in science.
I think to wrap things up, I'm going to just ask each panelist one lightning question to wrap up. Actually, I'm going to split it into two questions. So first, we'll start with, what are you most optimistic about? Where do you see AI making the big contributions in the near future? And then, because I think we all like a good challenge, I want to ask, what do you want AI to be good at? Where you're maybe not sure if it can do it, but you want to throw that out there for us to work on and see what we can do. So let's start with the panelists.
Yeah,
we'll start with Brian.
Okay, well, thanks for the wrap-up question. I'll try to keep it lightning and do it quickly. I'm most optimistic about the way that our tools are going to actually transform our national security science posture. All these things that we've talked about doing, we are without a doubt going to go bigger, faster, stronger, and it gives us the opportunity to get some advantage for us as a nation in our defense and security space that we wouldn't otherwise be able to get. Now let me go for the thing that I hope. I hope that we quickly see that these tools advance from not being able to help us solve problems, but as Rick said, sometimes the art is in formulating the most crisp and incisive problem that you can come up with and generating a hypothesis that you go out and test. And getting to that point is the real art of science. And so my hope is that we can use these models together with human creativity to formulate those hypotheses really quickly and then go attack them and get solutions like we've never seen before.
I think we're starting to see hints of that. So I think we'll see that advance a lot. Prasanna.
Yeah, near term, I see AI helping us in energy production, both nuclear fission and fusion reactors, starting from materials for these reactors, new material design, all the way up to reactor design, and so on and so forth. How to improve these reactors and produce more energy. So clearly, the path for that is very, very promising. And I'm really excited about using AI to improve and increase energy production. Long term, very exciting avenues, like Rick, Brian, and Kurt already talked about many of these things. But one thing that I want to emphasize is AI has the potential to transform the very fabric of the scientific discovery process. Right now, we are talking about acceleration, but it will allow us to venture and explore into new areas which are otherwise not possible. So those are the things that I'm really excited about in long term, and I think we are on a very good path.
Yeah, definitely. And then to you, Court.
Thanks so much. Yeah, so what I am most optimistic about is really this partnership between industry and the US government, the national labs. I think the ability to drive scientific discovery through autonomous science, for finding new materials, like Prasanna said, for whatever application it may be, new batteries, energy production, and things in between, this ability for us to partner with industry is incredibly important. We've seen wonderful use of these tools already, and so I'm just optimistic to see what's going to happen, knowing that new models come out all the time, new capabilities come out all the time, and now with our ability to infuse it with our science, the sky's the limit. That said, I'm going to pick up on what Prasanna said. I think looking at the challenges for the future, looking at areas in biology where perhaps these models don't necessarily reason as effectively today, or they may not as we would hope to. I think it's an opportunity for us to really partner and see how we can really uncover what the genome and proteomics are.
Yeah, I think there are a lot of interesting areas of data that are not yet in a format we're good at, but I think there's ways to work with that.
Yeah, it's interesting. So Court's long-term thing is kind of what I'm kind of thinking in the near term. I think that reasoning models coupled with decent tool use, interfaces, will relatively quickly be able to master most of the tool infrastructure that we've built in science, whether it's bioinformatics tools, computational tools, and so on. I think that's on the near horizon. Of course, they need a lot of work to get to the point where we can reason in spaces like biology, where it's less axiomatic. But I think long-term, the real challenge is how can we use AI to lift billions of people out of poverty on the planet, right? I mean, that's the grand goal here. And we want the U.S. to lead in science and in energy and national security and so on. But the purpose, right, is to make life better for everybody. And that means that models are going to have to be able, for us to imagine how we can use advanced AI systems, not just to create faster, more interesting scientific discoveries, but how can we translate all of this into actual meaningful lifting of people's standards of living. And that it comes partly through technology, partly through reforming human institutions, reducing friction and getting big things done, whether it's building out power infrastructure, whether it's doing the building in the world that's needed in order to raise everybody's standard of living. And that is the big translational lift. I think science is at the heart of figuring out how to do that, but the road is going to be long in how we actually make that lift happen. And that lift is ultimately is going to tie to global security, because if we can raise the standards of living and raise the material well-being of lots of people, the world will be a better place and a more secure place. And so there's a long-term agenda here, in addition to getting having lots of fun in science for the next few years.
Yeah, I 100% agree. I think it's powerful how much something like AI becomes extremely human the more you think through what you're doing, how you're doing it, where you want it to go. Well, we're going to wrap up there. I want to say a huge thank you to Rick, especially, for putting this together, to all of our panelists, to our partners across the 9 different national labs, and excited to see where this goes. And I'm going to head down, maybe get some pizza and see some science being done. So thank you all.
Thank you.
Thank you.